I have no idea if this works or not, but it occurs to me that somehow I did not record a video for number 13, and it's kind of fraction intense. So I just want to make sure that I kind of step through this and make it available for anyone who's interested in following it. So when I look at this system of equations, my first thought is I'm clearly going to use elimination, right? And I want I'm going to multiply this second equation through by the number 2. Now, when I multiply by the number 2, this negative 3 that I have is going to become a negative 6, which is perfect because that will be the opposite of the thing above. And when I combine these equations by adding equal things to equal things, the 6x will go away. So the new version of this equation, right, if I simplify it, and that pen does not look beefy enough, I guess, maybe it is going to be negative 6x, and then we're going to have plus 8y, and that's going to equal positive 20. And then just for reference, I'll rewrite the other equation. That's positive 6 times x plus 5y, and that is going to still equal 12. Okay, so I have equal things, check. I'm going to add equal things on both sides of that, check, and I will get equal things. And the equal things I get is 13y on the left-hand side, and that's going to equal 32. So first thing, surprise, surprise, y is not pretty. Y is 32 over 13, and that is not going to simplify because 13 is prime. So we're stuck with that number. Now I need to find what x is. So I'm going to choose to take the top equation. I'll just write it down. So I'm going to write 6 times x plus, now I need 5y. 5 times, here comes y. What's y? This is y. It's y. 5 times y, so 5 times 32 thirteenths. And then that will equal the number 12. Not pretty numbers. So what I'm going to do is kind of model how I would do this if I didn't have a TI-84 Plus calculator. And I'm going to do it if I did. So my problem is I'm not great with arithmetics, but I've got 5 times 32. So this fraction in here is going to become 160 over 13. That's going to equal 6 times x plus, and then equals 12. So I'm going to subtract this 160 thirteenths from both sides. So it's going to give me 6x equals 12 minus 160 over the number 13. So what I'm going to do is I'm going to take this number 12 and I'm going to multiply it by 13 over 13. I'm going to turn it into thirteenths. When I do that, the denominator becomes 13. Surprise, surprise. That's what I wanted to happen so that I could combine it with this minus 160. But let me do the arithmetic here. I've got 12 times 13. I know someone's shouting like, you don't know what 12 times 13 is. I don't. Let's see, 12 times 13 is 156. And 156 minus 160, I think even I can see that that's going to be negative 4 minus 160 gives me the negative 4. So this equation has become, I think better than it was. It's become 6x, 6 times x equals negative 4 over 13. Okay, now in order to solve this for x, what I'm going to do is I'm going to multiply both sides by 1/6. On the left-hand side, that'll be nice. That just becomes x. On the right-hand side, it's going to become negative 4 over 13. And again, I'm multiplying by 1/6. So my answer is going to look like the number I get when I go 13 times 6. 78. There we go. So it looks like my answer for x is negative 4 over 78. That's crazy. So as an ordered pair, the solution to this system is x is negative 4 over 78, and y is 32 over 13. All right, so that's my kind of my workflow if I didn't have a TI-84 calculator. Now, I do have one of these, so what I'm going to do is immediately come back up to this step, and I'm going to try to do this entire thing like this. So first of all, let me get, I need 32/13, so I'll write 32/13, and it's going to be a decimal, but I can ask this calculator to display it as a fraction for me. Beautiful, I love that. Now I'm going to need 5 times that number, so I'm just going to hit 5 times, and I just go and grab it. Okay, so that's 5 times that. Now I need to take that away from the 12, so I'm going to have 12 minus that thing. Grab it. And there we go. And now I just need to divide that by 6. I'll just say divide by 6 or multiply by 1/6. And it gives me, uh-oh. This is a bit unnerving. Let's see. I did get the 4/13. This became 2/39, huh? That's not, oh. 78 divided by 2. Oh, it does reduce. Okay, yeah, of course it reduces. So that's actually not where I would leave my answer. I would leave my answer because it's so much better looking, right? -2/39, comma, 32/13. Right, there it is. So that's a lot of work. Do I have evidence that that's the solution? Let's consider that for a minute. Let's think about our options. So certainly one of the things I could do is I could graph both of my functions. So I launched one of my 2 favorite apps for doing such things. This time I used Desmos. Let's go ahead and type the system in. Our first equation was 6x plus 5y equals 12. And our other equation, the second one, was -3x plus 4y, that equals 10. So there we go. You can see that the solutions right here is where those 2 points meet. And it looks like it's almost like, you know, it's touching the y-axis somehow, but it's not. It's over here. And if I zoom in enough, I can ask this to give me the point where these 2 things intersect. And you can see the point right there. X is negative 5 point. Oops, sorry, I left it. Can I label that point? Well, I can see what it is. I want to grab a calculator here. Let me grab this calculator. Very good. So what I want to do is actually look at my numbers that I got as decimals. So there's my 32/13. Grabbed it. And I can ask this to also to display it as a decimal. So, whoops, go back, display it as a decimal, just enter, enter. So that was my y value. That's what I originally found. And it is 2.4615. So that's very strong evidence that this is the intersection. The other thing we can look at is our x value, which was negative, what was it? Negative 2/39. So I'll just go -2 divided by 39, and I get, yeah. So this point is the solution, right? It's the location where these 2 things meet. Other things I could do if I wanted to check these is, let's just go back to our standard view here. Let's see with the OneNote. There we go. Nope, not that view. I wanted this. There we go. That was a nice custom view. What we can also do is, because we're kind of good at entering these fractions now and putting them on the screen, like I could go up and grab, I'll go grab, okay, this right here was my value of x. I'll grab that and I'll just keep it on the stack. Let me go up and get the y value, which was, there it is. Grab that and put it on the stack. So now that I've got both of those, let me come back up to the original problem. Oops, it's right here. And I can scroll up and we can see it. So if I enter 6 times the x value, right, plus 5 times the y value, I should get the number 12. So let's try that. Let's go 6 times the x value, enter, plus 5 times the y value. Oops, there's the y value. Enter. I should get 12, and we do. Now it's that's a great relief. But if we didn't get it, then I would spend some time trying to see if there's a mistake I made, perhaps. But at this point, because I saw the solution graphically, and because I just got this 12, I don't think that we have a problem. Let's go ahead and check one last thing, the second equation. So I'm going to go negative, and you can see how I enter the negative. I'm entering this button down here. So -3, and I need to multiply that times x. I'll go grab, this was the x, and then we'll hit plus 4 times, and let's go grab the y. There it is. And this should equal 10, and we can see that it does. So, you know, it is not unreasonable, but one might argue it's not kind to have problems like this. But I think every once in a while, it's nice to know, you know what, given the tools and maybe given just a few questions, it's not unreasonable to think about finding locations like this. Even -2/39 and 32/13 is a place on the Cartesian coordinate plane. This is Mr. Roberts. I'll talk to you later.